So, hello and welcome back. Let us look at this question now. Second example of simultaneous equations. Given a rectangle with the following dimensions, x and x, y and y, and the following information, solve for the values of both x and y. So I'm going to give you the area of the rectangle. The area is equal to 20 square meters. And the perimeter of this rectangle is equal to 18 square meters, right? Okay. So can anybody tell me, how do we solve this? What has been given to us? Area has been given and perimeter has been given, right? It's not necessarily 5 and 4. What you need to do is you actually need to solve it. It may be or may not be, because it needs to satisfy two conditions. It needs to satisfy both the area and the perimeter. 5 and 4 might only satisfy the area and it satisfies the perimeter. So, okay. Well, he is right, but I'm saying maybe. Did you solve it, or did you just, you did it by inspection? Right, so that's very good. So let's see if we get that. Now, given that, let me just see. Let's see if we have a quadratic or what we'll have here. Okay, so can anybody give me an equation which was not given here for the perimeter of a rectangle?
Perimeter of a rectangle.
Right, which in this specific case, that's area, sorry. So the first equation is area is equal to length times breadth. Now you need to make it specific over here. This is going to be the area is actually equal to, which was given, it's equal to 20 x times y. And the second one here for perimeter, you agree with me, it's x plus y plus y. So the perimeter is 2 times the length plus 2 times the breadth, which in this specific case is 18 is equal to 2 times x plus 2 times y. Okay, now given that we have this, we have two equations with two unknowns, we can now use what? Simultaneous equations. Alright, now which of these are the easiest to manipulate in order to solve for one variable? Is it this one or is it this one? Well, the truth is it doesn't really matter, so which one? That's equation 1. This is equation 2. Which one? 20. So equation 1. So do you agree with me that if we want to solve for y here, or you could solve for x, but let's solve for y.
Divided by x.
We divide both sides by x, and then we get y is equal to what?
20x.
20 over x. And let's call that equation number 3. So if we look at equation number 3, people, equation number 3 was derived from equation number 1. Okay, so that means if I want to reinsert this, where must I put it into?
Number 2.
Into equation number 2. So let's do that. Let's substitute equation what now? 3 into equation 2. So let's see what that looks like. Equation 2 is 18 equals 2x plus 2 times y, and we solved for y. Y was 20 over x. Do you agree with that? Now, as you can see, if I simplify this, just for the sake of clarity, that's going to give me 18 equals 2x plus 40 over y, right? I mean 40 over x. Now, here's a fraction involved. The moment you see this fraction, we want to get rid of it. Ahad, what do we do? Okay, so as you've pointed out, we now need to use the LCD, and the case here is the LCD is x. So we multiply everything by x, I end up with 18x is equal to 2x squared plus 40, right? There needs to be an x. Okay, so now we can clearly solve this algebraically, and we say, okay, that's 2x squared minus 18x plus 40 is equal to 0. There's a common factor that you see there, Kauthar. What is that factor that can go into each? 2. Right? So divide everything by 2 because it's an equation. Remember, if it's an expression, you can't just divide. Okay, so let's use sky blue over here is equal to what? X squared minus 9x plus 20. Very easily. So if we look at the factors here, you have x and x in each bracket. Are you with me?
Factors of 20 give you 9.
Factors of 20 that you add to give you 9 is 5 and 4. Okay, and both of these are going to be negative. And that gives you a solution saying that, okay, therefore the one x value is x is equal to 4, the other x value is x is equal to 5. Okay, now if we go to the equations that we had, remember we solved the equation for y. We said y is equal to 20 over x. So I'm going to put that over here. That's y equals 20 over x. From this, you know, we had x equals 4 and we had x equals 5. We're now going to solve for both of them, which is clear. We can say, okay, y must be equal to 20 over 4, or y must be equal to 20 over 5. And this is going to give you 4 and this is going to give you 5. So if we state these as coordinate points, we can now clearly see that this coordinate is either 4 and 5, and this one here is going to be 5 and 4. So well done, Ahmed. Okay, so very clearly, just look at this over here. That's the question that was given. If you substitute in 4 and 5 into an equation for the perimeter, it equals 18. And if you substitute in 4 and 5 for an equation for the area, it also equals 20.
Wait, so it's not O, it's N. Okay.
It's or, because there's one set of solutions or the other set of solutions that satisfies it. And both of them don't satisfy the equations at the same time, because you're going to use one set at a time.
Oh.
Right? Yeah. Okay. Now guys, if you want to test the solutions, you simply go back to the original equations 1 and 2 and you substitute in your values. So if I give you a set of equations and solutions and I ask you a question, and that question is, are these a set of solutions? Then what do? You substitute. You don't go work it out and you see if you get the same answer. You go and you substitute it.